I'm now going to hand it over to Mr. Mike Emmendorfer, uh, Field CTO at Calix, who's kind of naturally going to hand on to talk about the consolidation of OLTs and BNGs and end-to-end slicing again.
That's right.
Great.
Okay. Thank you all for your time today. So today we're going to talk about a couple of technologies here. So as Craig said, we're going to talk about the consolidation of the BNG and the OLT, essentially what we're calling OLT with disaggregated BNG. And we'll talk about some of the next generation PON technologies, some of the business drivers and the technology options. And then we'll look at end-to-end network slicing. All right, so we think that these three technologies combined are going to be game changers for the future. So the next generation PON technology, so in the 50 gig era, end-to-end network slicing, and we'll talk about that, everything from the edge of the network through the core. And then we'll talk about the OLT with the disaggregated BNG architecture. These three technologies will enable the operators to consolidate network functions to provide a lot of processing at the edge of the network. And this enables then the operator to have, let's just say, a 50 gig OLT or beyond that can enable both access and aggregation layer consolidation as well. So it's beyond just network function consolidation. It's also access and aggregation layer consolidation could take place. The use of PON slicing technology as defined in the ITU with Supplement 74 that will provide that programmability of capacity and QoS parameters and latency for groups of subscribers we think are also going to be part of this game-changing environment in the future. And all of this will enable operators to have more revenue streams out of the PON network, where in the past, point-to-point Ethernet technology may have been used, certainly for business and cellular backhaul or mid-haul type applications. We see that in this 50 gig era with network slicing, there'll be an opportunity to use more PON technology instead of optical Ethernet. We think that PON will have then the highest capacity at the lowest cost per bit, and we'll also think it's going to be the most sustainable approach when comparing it to other networking technologies. So what are the drivers beyond XGS or 10 gig PON? We've identified a few of them, first of which certainly is going to be business services. So that small, medium, and large business that wants to have true 10 gig or 25 gig. If they're asking for 10 gig today, they'll be asking for 25 gig during the life of this next generation PON technology. So that's where looking at the capacity needs for business services comes into play. Of course, the use of network slicing technology could enable the use of a private network. One of the drivers of point-to-point Active E when serving the business community, let's just say large enterprise or medium enterprise, they want it to be a dedicated network. With the use of PON slicing and overall end-to-end network slicing technology, the operator could provide essentially that same functionality. Next up, I talked about in this next era of PON, in this 50 gig era with network slicing, the use of PON technology as the aggregation layer. This aggregation layer where typically it's been used for point-to-point Ethernet, for like mobile xHaul or even Wi-Fi transport at venue locations or throughout the community, or even at distributed access, where you have a variety of technologies that might be in an MDU or even a cabinet location, that its connectivity to that access layer is going to be point-to-point Ethernet to the aggregation layer. We think that 50 gig and network slicing could be used for those cases as well. Next up is going to be residential services. So this is going to be one of the lowest drivers for the use of beyond XGS technology, but the bandwidth wars or Nielsen's law will continue. We do not think it will continue at the same rate of 50% compound annually like it has for nearly 40 years. We think it will slow down. The capacity just isn't noticeable these days. when we're talking about some of the speeds that service providers are providing to their customers. The other is going to be customer traffic will continue to grow, and we have some projections on that. When we look at all of those segments and then look at some of the use cases within each of those segments, we looked at some of the needs for the capacity, so the gigabits that would be required to facilitate those particular use cases in each of these areas. And you can see here that when comparing it to 10 gig and 25 gig and 50 gig, where the technologies, would be needed. Some of this information for the 5G mid-haul and backhaul came from the O-RAN specification, Working Group 9. They provided to the service providers how much capacity they should expect to have at a small, medium, and large site. So with this combination then of all of these different use cases, this is an opportunity that 50 gig PON technology could be used to consolidate or converge all of these services to one infrastructure, PON. All right, so I touched on this earlier. So this is Nielsen's Law. I'm sure that many of you have seen this before, but Nielsen's Law goes back all the way to 1984. And it basically says the high-end maximum internet service tier grows at 50% compound annually. It's been pretty accurate over its life. But as we highlight where we were in 2022 and 2024, you can see here that we, as an industry, surpassed Nielsen's prediction of a 50% compound annual growth rate in these years, in 2022 and 2024. For example, in 2024, Nielsen's Law would have predicted 3.3 gigabits would have been the maximum service tier offered by a service provider for residential services. As you can see here, I've highlighted a few countries that had service providers offering far more than what Nielsen predicted. Will this continue? So will Nielsen's Law continue to grow at 50% compound annual growth, and will service providers essentially match or exceed Nielsen's Law? I don't think so. There are a few reasons why. I think in 2035 and 2036, Nielsen's Law will break for some of the reasons of where PON technology is in its evolutionary curve. As I said earlier, speeds just aren't noticeable. As we get higher and higher, those drivers for capacity and those drivers for speed just are not going to be needed or noticeable. And also the economics. The economics to sustain, let's just say in the 2034 timeframe, a 200 gigabit service tier, it could be quite costly. There is another side of this equation. Beyond service tier, and it's what our customers actually use, and that's going to be traffic growth. So as we look back in the year 2000, the busy hour, busy day traffic utilization was 6 kilobits per sub. Okay, this is source data. I was at Charter Communications at the time, and this is about right. So if we look at 6.1 or 6 kilobits per sub in 2000, by 2022, we went from 6 to 3,500, representing a 33% compound annual growth rate over those 22 years. If we look over the last 10 years from the sample size here of 2012 to 2022, you can see a 31% CAGR. And then the last 5 years from 2017 to 2022 at 26% compound annual growth rate. You can see that it's declining, and there are a number of reasons for that. Essentially, the economies, the law of large numbers. Essentially, you have more customers, and more bandwidth being consumed. It's hard to sustain a growth rate of this. But over these years, I've seen it go up higher than these numbers over a given year, or lower than these numbers. So, I'm sorry, I hit the wrong button. There we go. Thank you very much. Good, thank you. All right, so some predictions. If we predict as all the way to 2030, a 20% compound annual growth rate, or 2040, a 20% compound annual growth rate, we would be at 15 megabits per sub busy hour, busy day, or 93 megabits per sub, busy hour, busy day in 2040. So as we look at the projections then, each one of these lines represents a number of subscribers sharing capacity. This is beyond the technology or the access layer technology. This is about these subscribers sharing capacity of a link. Could be a PON link, could be a DOCSIS link. And as we know, there are some capacity limitations, of course, to sustain or to support the very high numbers of subscribers for PON technology. But of course, as we know, DOCSIS technology can support high subscriber counts. But each of these lines represent just the traffic growth at 20% compound annually, all the way out to the 2040s. So as we overlay then, passing a speed test based on these projections, then we can kind of see how long a given PON technology may last. Like, for example, GPON technology with a 1 gigabit service tier might last until the 2030s. As we look at XGS technology, it will depend on your service tier. If you wish to pass a speed test, depending on how many subscribers you have sharing a link in an 8 gigabit service tier, based on those projections, it might last 2027, 2031. This next illustration illustrates the impact of the service tier. If you want to pass a speed test and you go with an 8 gigabit service tier or a 5 gigabit service tier, it could dramatically influence how long that network may last before you may have to spin those top service tiers off of XGS over to another technology like 50 gig. All right, let's look at 25 gig. So a 20 gigabit service tier was offered. We saw it offered in 2024, and that was using 25 gig PON technology. So as we look at that technology being used for residential type applications at the scale of 32 subscribers or 64 subscribers, this estimates how long that technology may last to support the traffic growth and to pass that speed test during busy hour, busy day. So this is why we think that 25 gig just isn't enough capacity for that next step. And you can see here that as we look at 50 gig PON technology, I'm just identifying how much capacity would be available for a host of those services that I talked about earlier, whether it be residential services, mobile xHaul, business services, transport, or aggregation functions, et cetera. So a lot of that will depend on how many subscribers you have, what's your compound annual growth rate, and what your service tier offering, and if you want to pass a speed test during busy hour, busy day. As we look at the PON technologies to support those, we all know where we are today with XGS technology having the capabilities of about 8.5 gigabits, 25 gig PON with its 21 gigabit of capacity. And as we know, it's really a combination of two different standards, the IEEE and the ITU. So 50 gig PON technology, defined by the ITU in this case, has a number of technologies that we'll touch on in the following slides, but it has 42 gigabits worth of capacity. And that 42 gigabits of capacity will provide enough capacity to support all of those use cases to allow the operators to reduce their reliance on a point-to-point optical Ethernet overlay network and put more and more of their network on PON technology. So we think the next step beyond XGS is 50 gig. All right, there are a few other considerations. So as we look at the ITU has defined option 1, option 2, and option 3 for the upstream. Those wavelengths are going to be XGS for option 1 that 50 gig could use if XGS is not there. Option 2, 50 gig could be used for if GPON's not there. And of course, option 3, right in the middle between XGS and GPON, if both are in use. One of the key things about this next generation network, as we look at the move from GPON to XGS to 50 gig that may use option 3, and in the future 100 gig. We can see that if we use the GPON wavelength for that one day in the future where we'll need 100 gig or multiple 100 gigs, that could occupy the GPON spectrum. So the transition strategy that operators could and should consider, if they have GPON and XGS, use option 3, and then with 50 gig, and then move to 100 gig once GPON is reclaimed. The other benefit and reason why we're looking at 50 gig as that next generation technology and skipping 25 is the use of dual rate receivers. 50 gig can support 50 gig by 25 gig ONUs and 50 by 50 gig ONUs on the same fiber, the same wavelength, and the same port. And the real cost of 50 gig is the upstream. So we think that this 50 gig by 25 gig ONUs will provide that the operator economic flexibility to have a lower cost ONU for those applications and service drivers that might not need 50 gigabit upstream. We'll transition over here to network slicing and PON slicing. So this is an end-to-end view of a network slicing architecture. I've identified, looking from right to left of this image, the use of IEEE Wi-Fi slicing or 3GPP slicing, PON slicing, and of course, IETF network slicing. So first up, what is a network slice? Network slicing takes a physical network interface and partitions it logically. And that partition could be called a network slice. And that network slice could be for bandwidth, QoS, or latency parameters. It can be statically configured or dynamically allocated, and maybe even with the use of AI in the future. So one of the things it can do is have a minimum guarantee or a maximum capacity, or both. This is an illustration then of an end-to-end architecture that would begin with Wi-Fi or 3GPP slicing that would interface with an ONU that supports network slicing at the chip level and above, as well as the OLT at the chip level and above. And then from, let's just say, a consolidated OLT architecture, you could begin the IETF network slice using segment routing. An end-to-end network slicing architecture. So a little bit more on what PON slicing is. PON slicing then would allocate then that physical network interface for a configurable capacity and latency properties for groups of users. And those groups of users could have a committed information rate and could also have an excess information rate. One of the interesting things about PON slicing technology is that any traffic above committed information rate that's been allocated to that slice or members of that slice, any unused capacity could be used by other slices or across the entire PON interface, thus not wasting bandwidth. If we look at optical Ethernet technology, you're framing it up. You frame up that network from the physical network, like for example, a wavelength and ports on both ends. PON slicing is a very efficient way of providing this capacity. Each slice will have its own DBA, and all of those DBAs will be controlled by a hierarchical scheduler. Here's a couple of use cases from Supplement 74. This is grouping ONUs to a particular slice. Pretty straightforward. The other approach is going to be more of an application-based approach that could implement many slices from an ONU. All right, OLT with disaggregated BNG. So as we look at where we have been for over 30 years, the use of a BNG has been typically a traditional BNG is a physical network function, a physical device. Maybe in this modern era could be a white box, so a PNF function or a physical BNG. And this image was taken from Broadband Form 459. So as we look at the disaggregated BNG, we've highlighted then the management and control plane in blue on top, and of course the BNG user plane on the bottom. Same functions, just disaggregated. So as we take a look more closely at the disaggregated BNG user plane and its core functions and the additional functions that could be part of the user plane, I've highlighted in yellow some of the most important functions of a BNG, and that's going to be the traffic management function. That traffic management function will ensure that the services that you offer to your subscribers for downstream and upstream bandwidth and latency and overall capacity is enforced at the traffic management layer. There are some other additional rules like QoS functions and remarking, and then also subscriber packet statistics counting. That's all part of the core function of a BNG user plane. There are additional functions. Those additional functions could be lawful intercept functions, could happen, as well as subscriber routing and local control plane functions. So as we look at the future and of the next generation PON technology, and also some of the network slicing technologies that we talked about, is the architecture that we began deploying over 30 years ago with the DSL architecture of centralizing all traffic management to a common place called a BNG. Is that the target architecture that we should have in the 50 and 100 gig eras? So as we look at this, those yellow boxes that I identified before are here, and they're the subscriber packet statistics and the traffic management functions and QoS parameters, the core functions of a BNG. We've looked at for many years now this virtual BNG, but it's beyond a virtual BNG because it's going to be a virtual BNG infrastructure, having the BNG servers as well as the leaf spine networks. And then this is the traffic flows. We're hairpinning traffic in and out of this network. North-south, east-west flows. As we look at an OLT with a disaggregated BNG, this pushes all of that processing down to the edge of the network. And you can see here that the PON DBA and MAC and PHY and the yellow boxes represent the traffic management functions. This is not a new architecture. This is an architecture that began in 1999. This is how cable did it. Cable didn't use BNGs. They pushed all of this processing to the edge. That's why they didn't have to deploy BNGs. They had the access layer, DOCSIS in that case, and also the traffic management functions all happen on a single box called a CMTS and later a CCAP. When cable entered the PON industry, they defined in DPX the use in 2010, the use of an OLT that would do these functions I'm highlighting here. We saw Verizon publish many papers and press releases in 2018 that combined an OLT with a BNG. And now we have seen in 459 talk about the definition of describing the disaggregation of a BNG and where those functions could live. So as we look at this next generation era, we're going to look at consolidating some of these functions to a single SOC. So the question for our industry is this: as we look at the evolution of the BNG and OLT in the 50 gig and 100 gig era, do we want to have per 64 homes, or per 64 customers, or per 32 customers, traffic hairpinning in and out of a BNG architecture? Or would we rather have all of that processing done at the edge of the network at line rate, non-blocking, where the customer, everything north of that is simply packet switching? This is an illustration of such an architecture that combines all of those things I talked about earlier. It looks at all of the different use cases, the use of PON slicing technology, the incorporation of a BNG function or traffic management function, the routing function for segment routing for the implementation of IETF segment routing, all being managed and controlled by orchestration and domain controllers. This is it. This is the summary of the slides. 50 gig, we think, is going to have cost flexibility for both 50 gig and 25 gig ONUs. 50 gig will enable that end-to-end network slicing architecture to support all of those use cases. 50 gig and network slicing could have PON for both access and aggregation. And finally, the OLT with a disaggregated BNG architecture could be the place where we place all of the processing at the edge of the network, and everything north of it is simply packet switching. With that, I thank you.
Right.